Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage, Glen Ellen, Illinois. This video today is going to take a look at three separate examples, and of course this is the C++ programming language, and we're going to look at Struct, basically structures, the step we take prior to teaching full-on object-oriented programming. So just because a structure, at least the way we teach it, is generally just data all put into one little, a bunch of data put into one object, or I call it an object, one struct. And then when we get to object-oriented programming, we kind of just turn the word struct into class, add a few little odds and ends, add some functions to it, and that's what the beginnings of object-oriented programming is all about. So here is the first example. And this is all everything's out of place, everything's not working, but you kind of get a feel for what's going on. Let me bring this down a little bit so we don't need all that here. So first thing here, we don't want to use we don't want to use namespace std. That's just something we try to stay away from. And again, I always get the reasoning why people use it, but at the end of the day, when I'm told it's more professional, and I've seen it out in the world, it's more professional to just do this way. And I know it's a pain in the butt. It looks like you're putting std : everywhere, but it's all for the better good here. So let's see. That's our first step, is just getting rid of all those problems. And now the things that come up are citizen1 and citizen2, because we have not written the code to make all of this work. So before we get started, let me see where we're at with our compiler. I guess I'll bring this back up here. I'll rebuild and see where we're at. So you can see all it is citizen1, citizen2. Okay, so yep, so far all is good. So now we can start filling in the details here. So we say fill in the code to initialize a structure named citizen1. Okay, so we say, okay, so taxpayer, just like I could say, just like I could say int a equals 0 or something like that, I can do the same kind of thing with any data type that I create. These are called abstract data types. And I call the base data types, like long and float and char and int and all those kind of data types, not string, I call those like atomic, because those are what the CPU can actually work off of. Basically 1 byte, 2 bytes, 4 bytes, or 8 bytes of storage, either on the CPU or in RAM, is basically what those data types can handle. And anything larger than that is usually a collection of different data types. Like a string is actually 28 bytes of storage. A character array is what the C way of doing a string is, and the string class is the C++ way of doing things, but it holds a ton of stuff under the hood. So it's more of like a molecule than it is like an atom. It's got all sorts of stuff working together. And so goes a struct. Just like water is 2 hydrogens and 1 oxygen, a taxpayer is a string of long and 3 floats. And a string, and that's where things start to get interesting. Like with the string class, do we really care how it implements everything under the hood, as long as it works as they say it works? And that's where as we move into object-oriented programming, we have to think that way. We have to think like the other people who are going to use our code, who are going to use our class or struct or objects, create objects, and go ahead and say, well, what should they be allowed to manipulate? What should they not be allowed to manipulate? What are the data types under the hood? And you want to set it up like string class, where they don't have to think about it. They just use it, and it just magically works. And as long as you've put the research in and you've found a way to make it work nicely, then, and quickly and efficiently with as little amount of memory as possible. Not always, but that's the goal. But that is the end goal of what we're trying to get across here. Okay, so just like I can set things up that way, I can set things up the same way here. Where I say taxpayer is my data type. The name is going to be citizen1, according to what they tell me here. And I can set it up, and actually, it's weird. I can do things this way. I don't have to set it up and do citizen dot. So I can say here his name is Tim McGinnis. Hello, Tim. Oops, mix. That's not it. Tim McGinnis. His social security number. How many laws are we violating keeping this number? And I don't know why they keep this as a long, because a 9-digit social security number fits within an integer. And in this version of C++, long is the same data type as int when it comes to the size of a long. If we wanted to use 8 bytes of storage instead of 4, we'd have to use long. Like, come on, guys, get your stuff together here. And the tax rate is 35%. Holy moly. Sounds about right. With everything I do, I end up paying quite a bit of taxes. That's how the world works these days. But anyway, let's not get into any of that kind of. So that fixes a lot of the stuff you see down here. Citizen 1. Oops. I don't know where I did it. I was just blanket filling in all the STD colons everywhere. But now you can see all of Citizen 1 is okay because I defined it. And now let's do the same thing for Citizen 2. The taxpayer is the type. Taxpayer is the type. Citizen 2 is the object, if you want to think of it that way, is the structure we're creating. His name is John Kane. His social security number is 278 990 582, and that's not the important part, obviously, of this assignment. But there we go. That's how we initialize everything. And yes, you might say, "Oh, there's five things here." And now I'm actually kind of curious at the moment. What does it fill in anything for those values? Yes or no, right? Worry about those warnings in a minute here. So Citizen 1, yeah, it does fill in zeros for all the other items. So according to us right now, Tim McGinnis has no salary, has no income, and has no taxes due. And same will go for John Kane here because of the way everything is set up. The curly braces basically say fill in as you can and fill in order. Here's the name, here's the social security number, here's the tax rate, and anything else I don't explicitly mention gets the default value of 0. Okay, let's see. So this needs to go down here because this is basically the given stage, right? The givens, and then now we need the input stage, and then from there we do calculations. And so calculate. Is it supposed to be like this? Is this supposed to be in front of this? I guess this is just all, like fill in, prompt the user, read in the code, determine. This is all, like the output stage and the calculation stage are kind of combined here. So calculate for Citizen 1, fill in the prompt to enter the user to enter. Okay, so here's a prompt. Enter income. And if I want to be fancy about it, I can go Citizen 1 dot, and then you can see name, and then I can put a colon there. So that way, for Citizen 1, I can go right to his name and go, hey, give me Tim Guinness's name, or give me his income. And then I can read that in, and I can say, okay, fine. And I can read that in directly. I don't have to create a secondary variable for this or anything like that. Citizen 1 dot, and we can put that into his income. And we can do the same idea here for the fill in code to read in this income. And then determine, and then from here we can calculate the amount of taxes. We're not going to prompt the user for that information because that information is given to us here. We know everything we need because the taxes is the tax rate times the income. We know the tax rate from the givens, and then the user gives us the income. So we can go ahead and say here, to finish this thing out, I can just go ahead and say Citizen 1 dot, and say that, I just forget the names, of course, as I'm trying to talk and think, dot taxes. I didn't name them, so they don't make any sense to me since I didn't name them, equals Citizen 1 dot income times Citizen 1 dot tax rate. Okay, and then the same will go for Citizen 2. So again, this is, if you want to think of it the way I teach things, this is that stage 1, this is the given stage. And now, or stage 0 is usually, and then stage 1 is the input stage. And so, and you can see here, it's like, let's print all this out and let's do it like, this is an output stage stuff, right? All of this is output. And there's no reason not to combine everything into one. So I'm going to take everything you see here, this guy, boom, and I'm going to bring it up here into this part here where we're going to get the inputs. And as you could imagine, I can just, for this case, I can just copy paste. If you want to type it all out, you can. But I can just change the 1 to a 2, and everything should work out properly. Okay, and then I should have everything for income for Tim McInnes on the first part and John Kane on the second part. And so now the final step, now it makes sense to have this thing here at the start of my output. They just throw it at the front because it's like, why not, right? Like, no, that makes absolutely no sense whatsoever. And then, and if you feel better about this, there's the input stage. I can bring this down into the calculation stage, process or calculation. Right, IPO, input, process, output. Givens, I guess, GIPO, I guess, instead of IPO or something. Sort of givens, input, out, calculate, process, and output. And so now we do have everything that we need here. This is so we're ready to go here. We're like, okay, get all this ready so every time I print something out, I print it out with 2 digits of precision past the decimal point. Because that's what we want to do, right? Nobody ever says when you have 50 cents, nobody ever writes out 0.5. They always write out 0.50. And so got my name, got my social, got my, this is already done for us. I think we're done here. Let me just try it out. There we go. And that's pretty cool. Enter income for Tim McInnes. And let me see what values I'm just so I have everything here. The Tim McInnes made 30 grand. Enter the money for John Kane. He made 17. Oh, he made 60,000. Double. He is doubly as important as Tim McInnes apparently. And then you can say, oh, name Tim McInnes. So security number. He has taxes worth 10,500. Yep, that's exactly right for his tax rate. And John Kane, where his tax rate owes 17,400. And yep, that is it. That is everything. Part 1. We've redone the problem and done things with better practices than what the original problem has. Okay, so the second example kind of starts out in the same place where the code is just hideous, and we got to work our way through. Of course, there's many errors because they're trying to fill in all the gaps here and tell us what to do. So I want to fill in code to declare a structure called taxpayer. It's a little different than the first one. But it says here that there's 3 members, each of type float. And float, why would we use float when we have double? This is the year 2022. We are living in the future. There's no reason to live in the past. There's no reason to Python. Does Python even have the ability to use float? Because it just uses double for everything by default. I think you could probably work it back if you want to. But unless you have space requirements or you have speed requirements, there's no reason not to use double for these things. So let's see, tax rate it says here, and then it says income, and then it says taxes. And I'd be willing to bet that this third one is going to be calculated. Well, you're going to, we'll see as we go. So let's see. So we have our taxpayer stuff. We have our tax rate, our income, and our taxes, each of type quote-unquote float. Okay. So as we discussed before, this little line of code here needs to go down here. Just somewhere into the output stage. We'll get there in a minute here. So now we don't have any givens because everything is going to be given to us by the user. So we don't have any givens, but we are going to need, it says here, an array. This is what the different problem here. Instead of just individual objects, we want an array called named citizen here. Let's see. So it's the type is taxpayer, not patter, the taxpayer, and we're going to call it citizen. And then there's going to be 5 of them. And we can't initialize any of the data because at this moment, we don't know any of the data. The data is going to be given to us by the user at runtime. So that's as far as we can go if you want to think about this as the given stage. That's all we got. And so now here is the input stage, and then so they're trying to combine things, and so you're going to see here that we're going to combine the inputs and the process into one loop here. And I'm just going to go std::. Okay, please enter for 5 taxpayers. Okay, fine. And then they want 3 end lines. Oh my goodness! Here, let me just do my me just add some STDs here. Be careful with that. Very, very careful with that. I still think if they knew back then, they probably would have named it. I hope they would have named it something different if they knew if the term STD was there before. Before, whatever, you get the point. Okay, so let's see. So here are all this, just to kind of get that out of the way. We can get rid of those errors, and we can just kind of continue on here. Okay, so count starts from 0. Count is less than 5. So this is going to go from 0 to 4. There's still going to be 5 elements. But remember, again, the computers start counting from 0. That's the whole point of arrays. Human counting versus computer counting. And so, and just on this is pre-increment is never going to be slower than post-increment here. So it says, enter this year's income from taxpayer, count plus 1. So this is count plus 1 because, again, you don't want to be like, enter this year's income for taxpayer 0, right? That doesn't make any sense to a human. So on the computer side, we're going to be dealing with count of 0, but on the human side, they think they're adding it for player 1 or taxpayer 1. And then there's no reason not to just find this. No reason at all not to. Okay, and then, so this is the loop part. And for the first part of this, we had to do everything, we had to do the same parts over and over and over again for each individual object. But because we're an array, we can process this one element at a time. Okay, so let's process this as it says here. Let's fill in the code. So that would be a CIN. And then we would say, and this is the income, right? So this goes into citizen, is the array. The element is going to be count, not plus 1. We'll talk about that. This is for human, this is for computer. And then I say dot income. We input into that. Okay. And then we say here, now, after that's done, enter the tax rate for this, for taxpayer. Well, I don't know why they have why would they have the number sign, the octothorpe here, and not have an octothorpe there? Octothorpe here, octothorpe there, octothorpe everywhere. And then just move this over again and say, now fill in the tax rate. I can just steal this so I don't have to type out everything. And then dot tax rate. And then you can see here, fill in the code to compute. So this is input part of this. And then this is, right after this is the output part of this. Or I'm sorry, the calculation part of this. Where I say, can I do this? Citizen count dot, let me just make sure I get the right one here. Not going to let me do it. Dot taxes is going to be equal to citizen count dot, citizen count dot income times citizen at the count dot, come on, IntelliSense here, dot tax rate. And then they're adding an extra line for some reason, I don't know. That's just their prerogative, and I am not gonna change that per se. So this is all we need for the input. This is all we need for the, just to get all the inputs and then process the final part of this process, the amount of taxes that each player or each person owes. Alrighty, so there goes that part. And so now to continue on here, let's see, this is where the output starts. And then now it makes sense to put your precision in all of your formatting here in your output stage. And then taxes due for this year. Okay, end line. I personally, I'm just going to do it because I just want to do it. I have just a nasty habit of adding that little line of formatting. Then we can get rid of that. Okay, and then we're good to go there. And so now it says, fill in the code for the first line of a loop that will output the tax information. And so we're going to need a for loop, as it's saying, int. I usually use I for but they're using index. And remember what this is. We're starting from 0. We're going up to and including less than 5 and plus index. And then that should do that. And then this is ugly as all to bloody get out. And can we fit it all on one line? Yes, we can. There's no reason not to here. So let's see. So print out taxpayer number, and then print out the index plus 1. Again, remember, one more time, that computers are starting from 0 here when it comes to the memory, but when the human sees it, they want to see it from the starting from 1 standpoint. And then $, taxes, end line. And that should do it. Should do everything here. Hey, look at that. Okay, so I'm gonna, well, I can't do this. That's part of the problem here. So let's see. What is the income? 30 grand. What is the tax rate? 0.4. I think, yeah, I don't. What is the number? 40 grand. 0.4. 50 grand. I'm just putting in numbers just so we can make sure everything is working. I'm not even worried about it per se. Whoops, 700 grand. No, that's a typo. And so there you see tax. So taxes due for taxpayer 1, 2, 3, 4, 5. So 12 grand, 16 grand, 20 grand, 24 grand, 28 grand. So yes, these are calculating everything appropriately. And for me, why is there an extra line break here? I don't know. So in this case, I'm just going to go ahead and get rid of it. There's so many line breaks. Okay, excuse me. So the one thing I was alluding to, and I just forgot that I can't do this, is the fact that this is hard-coded for 5 elements. The 5 is listed here, the 5 is listed here, and the 5 is listed here. And if you're like, your boss is like, okay, I want to do 20, or I want to do 9, or I want to do 4, you have to go into this code and find all the places where those numbers are and change them. And even here, you're like, please enter the annual income and tax rate for 5 tax like, this is so hard-coded. And what we call these magic numbers. And this is not a good situation to be in, because again, if I want to change everything, I have to change this in at least 4 places. 1, 2, 3, at least that many, and then 4 places for this. And if you forget one, you have a very subtle bug that you may or may not find until way down the road. And that's a problem. And so if we can think this out ahead of time, then we can make this work. So what we do is we put an int here, and we say, I'll just say number of citizens. And we'll say 5. And then what I can do here is replace those 5s with this idea of the number of citizens. And so I do have to fix, don't worry about I'll explain that in a second, but I do have to fix this up. There we go. So something like this. Please enter the annual income and tax rate for number of citizens, taxpayers. So, and if there's 1, then it's gonna be off. But generally speaking, we don't want to write extra code for that one case where, 1 taxpayer versus 2 taxpayers. And it's such a weird thing because 1.02 taxpayers. 1 is the only number on the whole number line, the real number line, that gets the singular. But everything else, if it's 1.0000001 taxpayers, you don't say 1.00001 taxpayer. It's just not how it works. Okay, so anyway, coming back. So then let's just finish this up. Number of citizens, number of citizens. Okay, so now it does exactly the same thing as it did before, but now if I ever wanted to change this and your boss says, hey, I need 9 citizens instead of 5, you just go, oh, I don't know about that, boss. That's going to take me half day easy, maybe a full day, because this change is going to propagate through the whole system. And then you can spend your time, you can spend your time on Reddit, or you could spend your time on YouTube watching my other videos when all you're doing is changing 1 character in your code and recompiling it. And so the final problem here is, let me just bring this down to 2 so we can test it out, make it easy on ourselves. The only problem here is, why is this giving a problem? And the problem is, when I set up any type of array in C++ at least, I need to, the compiler needs to know how many bytes of data to set aside, of memory to set aside for this thing at compile time. And so even though this is screaming out this is a 2, this number can technically change between line 14 and line 17. So because it can change, because it's variable, there's no way the compiler can know how much data to set aside for this struct at compile time anyway. So to be able to figure that out, we throw a const in front. And that'll go away because now this number can't change. So when it gets here, it knows that there's an unchangeable amount of elements in my array, and then it can calculate everything and go from there. So just to finish everything off, let's do this. And so now you can see, please enter the annual income and tax rate for 2 taxpayers. Look at that. And the 50 grand at 30% and 65,000 at 40%. And now you can see it did everything for 2 people. And all I had to do is change that one character because now I'm thinking smarter and not harder. And I got rid of the idea of the magic number in my code and I replaced it with a const. And now the only question is, this is correct. 15 grand or 15,000 and 26 grand. Yep, so the answer is everything is correct here. We've done everything we need to do for this problem. We're good to go. One more to go. Okay, our third and final program to clean up is a circle program, where it's basically going to, and this is an example where this works for 2 circles that are individual, and we're going to redo this code such that it works for an array. And we're going to do the same thing like we did in the previous examples, where instead of it hard coding it to we're going to do 6 of them, we're going to hard code it so that we can select how many we want to do. So we say if we want to do it at compile time, at least if we want to do 2 or 3 or 4 or 20, that's our prerogative to set up that array as we've already learned. So just give me a second to get down to where I need to go here. There we go. And so, okay. And then it says also about determining which center is closer to the origin. We'll fix all of this up as we go. Okay. So here's a lot going on here. The center position of the circle in a 2-dimensional space. And I'm just going to go ahead and let me just go through this real fast. Look through this. Nope. Okay, I'm good to go. I feel much better. Oh, one thing first, before I even worry about this. Look how weird this is here. So first off, floating point numbers are good to at least 6 decimal places. This is only 5, first off. And how many mistakes are here? So pi is defined as 3.14159266535, and then God knows what the numbers come after it. It's irrational, meaning the numbers go on forever with no repeating pattern. And so if you look at this, first off, this is a float, but this is a double because of the way the number is being represented here in our program. And you can see that this number, 3.14158999999, is being condensed into float. And until we run the program, we don't even know what that true number is. And so the first thing I would do, if I ever was really wanting to use float, I would put an F in front of it. Now you see how everything changes. And now you get 3.141590118. That is the closest number that we can, the closest value we can get to this value that we're trying to approximate for pi. And so that's not good. I want double. And like I was saying, 26535. I'm going to look it up here. Let me just real quick here. Pi to 20 digits. 3.14159266535, and then it just goes on and on and on. And yes, I can get rid of this nonsense. But we don't need all these digits. You mouse over the thing and you go, oh, it's only good up to... Where is it only good up to, right? 793116. 793116. It looks like it's only good up to about here. See? By removing all those other digits, the number stayed exactly the same. 3116. 3116. So yes, all of these other digits do not affect the double, because double is only good to however many decimal points. This is 5. This is 15 decimal points, which is about the limit of what a double can give us. So this is the way to do things. And you could look to see if I move this down to 9.2 if it would be closer, but usually the compiler is pretty good at coming up with the closer numbers. So 15 decimal places is a good way to start here. Okay, so we were discussing we need an array of these things. Circle is the data type. I'm going to create circles, and I'm going to create, like I was doing before here, I'm going to say const int number of circles. And you can put in whatever number. I'm going to keep it easy on myself. I'm going to call it 2. And so there we go. So we're starting out with this const number, and we're saying, okay, now we have this, and pretty much everything else from here on in, this is technically a given. Like, I'm not a big fan of globals, just as in a modern way. So that is a given. These are the givens. Double pi, and then no function is using pi, so we don't really have to. It's fine in here. But yeah, you're right. It probably should be a global, but I'm just moving it out. So now here is the input/calculation stage. Inputs and then process and calculations. If I spell it, oh yeah, hey, I actually kind of spelled it right. Calculations, there we go. So this is where we want to go ahead and fill in and change all of this. Look at all that. Oh my God, it's a lot of just disgusting code. Everything up to here can be fixed up and made better. So okay, so what do we want to do? We want to loop for all of this thing. First off, I'm going to say for int, I'm just going to use I. Int I equals 0. I is less than number of circles. Plus I, and then I'm going to put all of this crazy nonsense inside braces here, up to here, I believe, and then we'll figure that out in a little bit. So this is going to combine everything as they were saying here. Let me just add the std : to everything. I'll do that step while you guys are maybe catching up. Who knows, since I can't see what any of you are doing. But there's a I don't know if you can hear the excitement upstairs. We are playing a hat in time right now, and it is for a 6-year-old. He's enjoying life, I guess. He gets a little frustrated, but that's what the internet is for. Oops. To help him through that. And of course, my wife is up there helping him too. While I make this video. There's a lot of C outs. My God, this is crazy. A lot of. You could tell I don't do a lot of. I don't do a lot of printing. All the game stuff, you never had to worry about printing to the screen. Even if I had to print, I would just call a function that someone else wrote. It would do all the work for me anyway. So as I go here, we're working our way through. Whoops, we're getting there. Oops, one more. Getting closer. All right. Okay, cool. So please enter the radius of the first circle. And we've done this before. We're circle number. And then we can say, let's print out I plus 1. Remember, again, computers count from 0. Humans count from 1. So let's make it easy for the person to understand what's going on. And then now, circles at the I value dot radius. And I don't know why it's not allowing me. Oh, because there's a, let's see. Dot radius. Excellent. We don't need an end line every single time. That's crazy. What kind of crazy people are doing all these things these days? And then you go enter the x coordinate of the center. We don't have to, because we know we're dealing with circle 1 here, so we don't have to worry about that. And let me just change this. Let me just copy this guy. So there's center x. All right. So if you haven't already done so, it probably makes sense for you guys to do this at 1.5 speed or something like that. I know I do that quite often when I watch a YouTube video when I'm trying to learn something. And so there are the 3 inputs, right? Everything else can be calculated from the radius, right? So center point, we need to know that from the user. Same with the radius. But the area is pi r squared. The circumference is pi diameter, which is 2 pi r. And the distance from origin, which is 0 point, is just basically the square root of center x squared plus center y squared. So everything else can be computed from these 3 pieces of data. And that's why we're combining everything into one thing here. So again, I'm going to say, okay, the area is equal to my pi value times, and this is where things get a little crazy. It's like, why would you, pow is a very, very specific function it's a specific function for general use powers, like 6.2 to the 9.7 power and things like that. When I'm dealing with something like this, you can't beat a straight up multiplication. It's just there's no way. Whoops. There's no way that you can beat that. So pi r squared is the area. Pi times radius, okay? And then you say the circumference. All these little things, all these little errors. This 2, see how it comes up? 2, I mouse over, 2 is an int. 2.0 is a double. And this is a double. And this is going to be a double. 2 pi r. You could see that the radius is it's a float. Oh, did I never change? Oh, I never changed things up here after all of that. So let me just, these should be doubles unless you have a very good reason not to make them double. But we don't have that. So then now coming back here, 2 pi radius, now radius comes up as the double it's supposed to be. Good, so double times double times double gets me a double, which gets stored as a double. Hey, look at that, look at us go. And so here's the idea of that distance from origin, like I was just talking about. Oops. So distance from origin equals the square root of, oh my god, look at how crazy this is, right? So square root of power, and like, oh my god, right? So this is, the only reason this is going to end up being crazy is because there's just so much wording for each individual thing. But the square root, you can use the square root function for this. Oops, never mind. Or there's another function where we can basically get the hypotenuse. So I can call hypot, and I can supply basically the x position, center x, and I can supply the y position, and it will do all that math for me. This function's only been around for 10 years, the hypot function. And so at least 10 years, right? So let's see, C++ hypot. Just curious here. It is part of C++ 11, so 10 years old. I think a 10-year-old function should get more usage, right? All right, so nobody called me up when they were doing it, though. Okay, so we get the area, we got the radius from the user, and the center x, center y. And then we've calculated area, circumference, and distance, and that's all we need to do here. And all of this extra nonsense, maybe, let's see, distance, center, enter. Maybe we only need one. No, it was fine the way it was. But we definitely don't need all this extra code for the second one because it's all taken care of in the loop over and over and over again. So that gets us through the inputs and process stage. And now it's down to the output stage here. Okay, so 2 more things to do for our output stage. I guess technically our calculation stage. But let's worry about the output first, and then we'll come back and fix this up. So let me comment this out, because we need a way to calculate which of the circles is closest to the origin. And we'll have to figure that out. Well, that shouldn't be so bad, since the distance from origin is saved for every one of the circles. So let's just not worry about that. Let's worry about outputs. And so we need another for loop. We'll use the same for loop from before. And there goes that. And I put everything inside of here. Let me add a system pause here because I'm in Windows. Okay, so the outputs go as you would expect here. Let's see. So let me get rid of this. This does not need to go into the for loop itself. This can go outside of it. And so, okay, the area of the first circle. There we go. The area of circle. And then we go print out I plus 1 again. Is. And then there we go. And then, let me just go steal this again so I don't have to type it out every time. Oop, I don't have to worry about the seconds. I don't have to do any of this nonsense. All right. So okay, so again here, so there is the circle, there's the area, there's the circumference, and let's print out the distance since this isn't included here. The distance to the origin. Origin of the circle. Since it's already printed here, I'm not going to do it over and over and over again. The distance to origin of the circle is, and just to keep everything nice and neat, I'm going to put everything like this, and we'll see when the printout comes how much more I have to do for this. And so now this is distance from origin, or distance to origin. It depends on, it's the same idea, right? It's the same number whether you're going from A to B or B to A. So let's just see what happens. Let's see what happens. Let's see does it compile? Does it run? I did hit. Okay, there we go. Enter the radius of circle 1 is 5. The x-coordinate is 6 and it's 9. Enter circle 2. Well, that's a lot. We'll have to fix that up. 1 radius and 6 and 88. And so there it goes. It prints out the area of circle 1 is, the distance to origin is. So these are all good here. I don't know. Again, I don't know why there's so many end lines. And this needs a lot of spacing. 1, 2, 3, 4, 5. I just don't know if I'm right again. Let's see. What about all these other ones? All these end lines. All these crazy end lines this guy likes. Let's make it a little more. Let's sanity check it a little. Let me just add numbers in. Let's just see where we're at. Oh, look at that. I had it, but I got to move this back over. Okay, so, but you get the point here. Now everything is coming out like it's expected to be. The area of the circle, 2 pi, whatever, blah, blah, blah. Origin, 2 times this, 1.40. Yep, this seems to be all right. And this seems to be good. And so now, let me just fix this up, and then we're ready to finish up the last step here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. Let me just... The formatting guru here, let's see. There we go. Everything's looking great. Everything's lined up. It's not fully justified, but at least it starts on the same column. Alrighty. So then the final step here is this guy calculating which of the circles is the closest one to the origin. So let's see here. The first circle is closer. Oh, but again, we're worrying about which circle. So it's indexing. So we're going to just presume that the first circle is the closest one, and then say, prove me wrong. So I'm going to start counting from 1, and I'm going to go as long as we're less than number of circles, I guess. I'm going to remember my naming for this. And so here, I can just get rid of all this nonsense here. This is our calculation stage. Okay, I guess we could call it closest index to the origin. And then inside of here, I can say if my circles at the closest, at I is dot distance from origin is less than circles of I dot distance to origin, then the closest index to origin is equal to I. Doesn't that make sense? Because we're saying, oh, this is the closest one. And then you go, nope, found one closer. Oh, sorry. I'm testing I against closest index to origin. Sorry about that. That'll never be true because is a number less than itself? Never. So say, okay, if the I at 1 is less than the I at 0, or if the circle at 1 is less than the circle at 0, then let's make that the new closest one and continue on through all of them until we find our answer. And then now we can use this one down below here. Are we using number? We're not. Are we using the number sign for anything here? Are we doing? Yep, we've been using the pound, the octothorpe. So let's continue. the closest circle to the original, to the origin is number, and then print closest origin plus 1 again, because that from the way the computer reads it to the way we read it. And that should do it. Let's do 3 circles just to be sure here. And I don't have to change anything else. That's the great part of this is 3 circles took less than no time at all to change in my code. Okay, so my radius is 2. Let's see, 3, 4, 5. So let's see, the radius here is 6, but the coordinates are 1, 1, so it'll be 1.4 units from center. And then circle 3 is the unit 7 and 5 and 12. And so I guess, I added 1 character, so I'd have to bring this back to make this level up. But okay, 3, 4, the origin should be a 5 for a 3, 4, 5 triangle. 1, 1 should be the square root of 2. And then 5, 12, it should be 13. But it says that the closest circle of the origin is number 2, which is absolutely correct. And so we can test this out a little bit more. Let me get rid of this extra one right here. So it tested out the middle one, one of the ones in the middle. So now, just testing-wise, let me just put 1s, 2s, and 3s. It should give me the circle number 1 is the closest one. So the first one. Okay, good. Let me add an end line here real quick. And let's try the final one, and then this really long video is done. So the end, so 3, 2, 1, and it now says the closest circle to the origin is number 3, which is correct. So for all 3 cases, we found the closest one. And ties will go to the first one we find, since I put the less than here. If you wanted less than or equal to, that would give me the furthest one in the list if they come out exactly identically equal. All right, so those are the 3 examples here, all cleaned up and ready to go. So if you have any questions, concerns, if I misspoke about something you need clarification, please let me know. Comment below here on the YouTubes, or you can get back to me at swardb, or get a hold of me at swardb@cod.edu, and I'll get back to you as soon as I can. So structs are done. Now we take all of this understanding, all this knowledge of structures and arrays of structures and whatnot, and now we start moving over into object-oriented programming, because ultimately, if I take this word struct and I replace it with the word class, and then I just go down here and put the little word public with a colon, nothing's different. My code will run exactly the same. Structs and classes are very much similar, at least in C++. Maybe not in the old C way of doing things, but in C++ definitely. So thanks for sticking out all this time with me in this video. Thanks for that, and I hope to see you guys in another video. Have a great day, no matter what. Take care, everybody.